8. Okay, question number 8 said an arc of a circle, of radius 13.5 cm subtends an angle of 105 degrees at the center. Then I say calculate correct to three significant figure: the eye, the chord, the chord length AB, I, arc length AB. Okay, they say we should take pi as 3.142. So they gave us the diagram. They say this is a circle, and we have this, and then we now have a chord. So this is our A, B, and here they gave us is 105, and then here they say it's 13.5. Okay, so this is center O. So this is very simple. Let's start with length of a chord, that is II. So length of an arc that we know. So length of arc is theta over 360 times 2 pi r, right? Which is what the theta is 105 over 360 times 2 times 3.142 times. Notice that I use 3.142 because that is what they say we should use, times 13.5. So if you do that, you are going to be having 105 times 2 times 3.142 times 13.5 divided by 360. So I'm having 24.74325. So approximation to three decimal places, three significant figure: 1, 2, 3. That is 24.7. Okay, so for I, they say we should calculate, you know that here is equally 13.5. So they say we should calculate the length of this chord AB. We can apply cosine rule. Okay, we can apply cosine rule to get that. We can just apply cosine rule to get that. But if not, okay, all right. So but they say that the length of the chord, it has a formula, but I'm still going to use cosine rule. The length of the chord said it has a formula, and the formula is 2r sine theta over 2. Okay, so you should know that 2r sine theta over 2, which is what? 2 times my r is 13.5, then sine 105 divided by 2. So what do you have? That is 2 times 13.5 sine 105 divided by 2, 105 divided by 2. So I'm having 52.5. So let's do that. So I'm having 2 times 13.5 sine answer. So I'm having 21.4205419. So approximate to three significant figures, 21.4 cm. Okay, now but let us try using cosine rule to know if we'll get the same answer. Okay, so let's call this place X, for instance, so it will be easy. Now cosine rule said that if we're looking for this place, it's going to be what? X squared is equal to 13.5 squared plus 13.5 squared minus 2 times the same 13.5 times the same 13.5, then cos 105. Okay, that is that if you have a triangle like this, and here is your X, Y, and Z, so that if you are looking, here is small x, small y, small z. Okay, so if you are looking for small x, it's going to be x squared will now be y squared plus z squared minus 2 times the same y times the same z, then cos that x. Okay, cos the side that is facing the x. That is exactly what I did here. So you can call this your x, your y, and your z, if you feel like. So that is what I use. So let's see if we get the same answer. So my x squared is going to be, don't forget we got 21.4. Let's see. So 13.5 squared is giving me 182.25 plus the same 182.25 minus, so 2 times 13, sorry, 2 times 13.5 times another 13.5, then cos 105. So I'm having everything to be minus 94.3, approximately 34. Okay, so if you do everything here, it means 182.25 plus 182.25, then plus 94.34. So let's have this 182.25 times 2, then plus 94.34. So I'm having that x squared is equal to 458.84. So x will now be the square root of 458.84. So my x is equal to square root of this, my answer. I'm having the same 21.4 cm. Okay, so any of the formula you like, you will still get the same answer. But myself, most of the time, I used to forget the formula for length of an arc. So I normally use the cosine rule to get my answer. Okay, so anyone you prefer is still correct. So we go to the next question, question number 9. So question number 9 said they gave us a circle, center O, and they gave us an arc with a chord that sustained an angle of 50 degrees, and they say that here is 7 cm. So they say we should calculate the length of the major arc, then we should correct to 2 decimal places. Okay, so if I'm using the major arc, that means this is the angle we are going to use. So my theta to use is going to be 360 minus 50. The reason is sum of angle at a point. Okay, you need to write the reason as sum of angles at a point. So the theta I'm going to use is going to be 310. So we know that length is equal to what? Theta over 360 times 2 pi r. Okay, so let us do that. So the length of the arc will now be what? 310 divided by 360 times 2 times 22 over 7 times the radius is 7. So if you do that, you are going to be having 310 times 44 divided by 360. So I'm having approximately 37.89. That is to 2 decimal place. Okay, approximately. So you see, it's very, very simple to calculate. Okay, so we move to the next question, question number 10. Told you we'll be solving 12 questions. So we are now in question number 10. And question number 10 said, in the diagram below, comma, O is the center of the circle, okay, of radius 14 cm, comma, angle XOY is equal to 40 degrees. Then I'll say using, okay, let's say find I question said the length of the major arc II said what is the area of the minor segment, okay, sector, area of the minor sector. So, and the circle they gave us this circle, they gave us the radius, 2 radii, this is 14 and here is 14, and the angle they gave us is 40 degrees. Okay, so here is our x and here is our y. Okay, so this is very simple. For I, we know that length of the arc should be equal to, don't forget that they say the major one, so we are using this place, that is 360 minus 40. So the theta we are going to use is what? 360 minus 40, which is what? 320. Okay, so we say 3, that is theta over 360 times 2 pi r, which is what? 320 over 360 times 2 times 22 over 7 times 14, right? Because the radius is 14. So we are going to be having 320 times 2 times 22 times 14 divided by 2520. So I'm having approximately 78.2 cm. Then I said we should calculate the area of the sector. So area of the sector is given by theta over 360, area of sector is equal, just say theta over 360 times area. Because it is area, we will have area of a circle, and area of a circle is what? Pi r squared. So we are going to say we are using the major sector or the minor one. Which one? Okay, the minor sector. So we are looking for the minor sector. So we are using 40 over 360 times 2 times 20, times 22 over 7 times 14 squared. So what do we have? So this is going to give us 40 times 22 times 14 times another 14. So divided by 2520. So I'm having approximately 68.4 cm squared. Okay, so that is that for that. We go to question number 11. So question number 11. Okay, so question number 11 said that the length of the minor and major arcs of a circle are 54 cm and 126 cm respectively. Okay, you now say we should calculate the angle of the major arc. Okay, angle of the major sector, or okay, sector. Okay, now we know that solution. So calculate the angle. So we say let the angle of the minor sector be theta. Then the angle of the major sector will now be what? Will now be 360 minus theta. I hope you know 360 minus theta. Okay, so first of all, the length of the minor arc, length of minor arc will now be theta over 360 times 2 pi r. Okay, why the length of the major arc will now be 360 minus theta over 360 times 2 pi r. Okay, so for the first one, they gave us that it is 54. So the first one is what? 54 is equal to what? Theta over 360 times 2 pi r. Okay, why for the second one? Then okay, let's make theta over 360 subject of the formula. So theta over 3, okay, we are looking for, okay, let's make 2 pi subject of the formula. So if we make 2 pi subject of formula, therefore 2 pi r, okay, will now be equal to this go here, that is 54 times 360 divided by theta. Let's call this equation 1. Now from the second one, we know that the length of the arc, which they gave us as 126, will now be 126 is equal to what? 360 minus theta all over 360 times 2 pi r. Okay, and then don't forget that 2 pi r, we have gotten it as this. So we have 126 is equal to 360 minus theta over 360 times, instead of writing 2 pi I, I'll write it as what? 54 times 360 divided by theta. Okay, so this will now help us to have that 360 can take care of 360. So if I cross multiply, permit me to clean here. If I cross multiply, I'm going to be having that this is 126 theta is equal to what? 54 in bracket of 360 minus theta. Okay, so let's see if 126 will divide 126 divided by 54. Okay, well, let us just clear the bracket. So I have 126 theta is equal to 360 54 times 360. So I'm having 19440 minus 54 theta. So this one coming here, I have 126 theta plus 54 theta is equal to 19440. So if you add these two, I'm going to have 126 plus 54. So I have 180 theta is equal to 19440. So therefore, theta will now be 19440 divided by 180. So I'm having that my theta, so 19440 divided by 180. So I'm having 108. So 108. So therefore, I'm now having that the other one will now be 360 minus 108. So the angle of the major sector will now be what? 360 minus theta, which is what? 360 minus 108, which will give you 252 degrees. So that is that for that, 252 degrees. Okay, so we move to question number 12, which is the last question I'm going to solve for today. Okay, so question number 12 gave us, so question number 12 said, I think it's going to be an assignment, so you try to solve it yourself. Okay, they say we should find, it's a very simple question, find the length of an arc of a circle, okay, of radius 15.4 cm, which subtend an angle at subtends an angle of 60 degrees at the center. Okay, so tell us what the answer is at the comment section. Thank you very much for watching. Those supporting us, we really appreciate. Please support us by clicking on that like button, comment, and then share the video to your friends. May the peace of the Lord be with you. For our newcomers, please subscribe. We love you all. Bye bye.